Good morning, class. My name is Corey Clark, and I will be giving you my presentation for MSCT 600, Congestion and TCP, how TCP protocols help to alleviate congestion problems within a network. Basically, congestion is a problem that occurs on shared networks when multiple users contend for access of the same resource. Now, congestion typically occurs under a normal multiple number of circumstances. It can happen in such cases where WANs and LANs connect together, or it's switches or routers where they handle a lot of inbound, outbound traffic for a particular node. Congestions can also occur where routers and core networks where nodes are subject to more traffic than capable of handling. Another thing is TCP networks such as the internet are especially susceptible to congestion because it is a connection-oriented based protocol that relies on acknowledgments to ensure that delivery occurs. So it's going to be kind of those ACKs and sends and all that will cause problems for it. There are several prevention methods that are used. One of them is slow start, another one's fast retransmitting, another one's fast recovery, and another one is congestion avoidance, which we'll each get into now. Basically, slow start, that's an algorithm that requires a host to start transmitting slowly, then building up to a point where congestion occurrence happens. The basic principle is to start by sending 2 packets, and then the next time you'll send 4 packets, and then 8 packets, and then 16 packets up until the point that you no longer get an acknowledgement, which means you've already congested the network. The basic point of this one is that it doesn't stop congestion, but it does prevent it from preventing an immediate congestion state. Another one, fast retransmit. Fast retransmit is an algorithm that instead of waiting for an acknowledgement until the timer expires, it resends it 3 times such duplicate ACKs are received. Since this occurs before a timeout period, throughput is increased. Another one, fast recovery. Fast recovery is used to replace slow start when fast retransmit is used. Duplicate ACKs indicate that a packet was dropped and congestion was not necessarily occurring. In this case, it is assumed that only the packet was dropped and that the network is not fully congested. The sender does not need to return to a slow start state, but it can transmit at half the previous rate. And the final one is congestion avoidance, which has 3 subsections under it. Congestion avoidance detects impending congestion conditions and actively manages congestion before it gets out of hand. Active management, random early discard, explicit congestion notification, and TCP rate control are all examples of how this is accomplished. The first one we'll look at is active queue management. Active queue management is when routers drop packets to signal the senders that they need to slow down. Some of this is the knowledge that bursts are inevitable. Keeping queue size small and actively managing queues improves routers' ability to absorb bursts without dropping excessive packets. If a source overflows a shared queue, all the devices sharing that queue will slow down. Another one is within this is large queues can translate into delay. Active queue management allows queues to be smaller, which improves throughput. The next one we're going to look at is random early discard, RED. RED uses statistical methods to drop packets in a probabilistic way. When dropping the packets, RED decides what packets to drop based on 2 criteria. The first one is minimum threshold, which specifies the average queue size below which no packets will be dropped. And then the second is maximum threshold, specifies what average queue size above which all packets will be dropped. Explicit congestion notification. ECN is an end-to-end congestion avoidance mechanism that provides direct notification of congestion, then indirectly dropping packets, like you have heard in the previous ones. ECN is designed for moderate congestion. When congestion gets excessive, packet drop techniques are still used. So basically, what this one does is that there's notifiers in the network that send it to the computers to let them know that the network is starting to get congested, and this prevents packet loss. The next one, TCP rate control, and this is the final one. TCP rate control is a technique used where endpoints can adjust their transmission based off feedback from network devices. So network devices similar to the ECN will also let them know that we got a full traffic load and we're incapable of handling any more. So for the basic overview of congestion, congestion again is just when there's just too much packets or too much activity over a network that's causing packets to be dropped or the network to slow down to a crawl, buffers are overflown. And of course, some of the techniques that we use, you got red, well, you got congestion avoidance. Sorry about this, I'm outside. Congestion avoidance, slow start, fast recovery, and fast retransmit. So that is my presentation on this. I hope you all enjoyed it, and I'll see you all in class. Thank you and have a great day. Bye.